You probably know the 80-20 rule, the Pareto principle, which states that for many outcomes, roughly 80% of consequences come from 20% of the causes. Mathematically, the 80-20 rule is roughly described by a power law distribution for a particular set of parameters. And many nature phenomena fit this distribution. I will discuss it in the next 5 minutes. The 80-20 rule, also known as the Pareto principle, it's named after the Italian civil engineer, economist, and sociologist Pareto, for he was the first to discover that income follows a power law distribution. Empirical observation has shown that the 80-20 rule fits a wide range of causes, including nature phenomena and human activities, such as 80% of social wealth is held by 20% of its population. A Microsoft report suggested that 80% of errors and crashes of Windows and Microsoft Office are caused by 20% of all the bugs. 80% of sales coming from 20% of the products. 80% of customers only use 20% of software features. In statistics, a power law is a functional relationship between two quantities, where a relative change in one quantity results in a proportional relative change in another quantity. This is the power law distribution. From the diagram, we can see it as a fat-tailed distribution. This indicates that smaller value random variables are easier to observe. One important attribute of the power law distribution is their scale invariance. For example, a shop's 80% of revenue comes from 20% of its customers, and among those 20% of customers, roughly 80% of revenue come from 20% of them. Maybe it is more easier to get the idea of scale invariance from this GIF. The average value is not that useful in the power law distribution. As we know in the normal distribution, most random variables can be observed around the average. Thus, knowing the mean value of the normal distribution is important, since it can represent the majority. However, this is not the case in the power law distribution. Imagine in a room, there is one billionaire and 99 working class people. Talking about the mean wealth won't make much sense. During the 2003 US tax cut, households can save $1,586 per year. However, this number alone can be misleading. Since the income is not normally distributed, actually, half families' tax cut is less than $650 per year. Because of the fat tail of the power law distribution, the extreme happens more often. For example, in the normal distribution, 99.7% of the data falls within 3 standard deviations of the mean. In practice, we can consider the event outside a certain range of the mean won't happen. Unfortunately, extreme events do happen in power law distribution. It is known for the capable of black swan behavior, such as bushfires, violent earthquake, or global financial crisis. The unpredictable of power law distribution. Adding sand to the pile eventually will cause avalanches. Researchers indicate that the frequency size distribution of avalanches obeys a power law distribution. But we can't predict under what condition adding a grain of sand will cause the avalanches. Similarly, it is very challenging to predict natural disasters as they follow power law distribution. We know that, such as bushfires, violent earthquakes, or global financial crisis will happen, but it is hard to predict when it will happen and on what scale it will be. We know that the global wealth distribution far from ideal, but don't know much what we can do to fix it. 4 takeaways. First, one attribute of power law distribution is their scale invariance. Second, the average value is not that useful here. Third, because of the fat tail of the power law distribution, the extreme happens more often. False. The unpredictable of the power law distribution. I'm always here at your service. See you in the next one.